Hi, good morning. I'm Region Prialas and today I'm going to introduce to you the delta and y transformer.
Introduction to delta and y connection. Part 1. So the delta is which more complex, so and confusing, and it is easy to mess to the y connection. So means na ang delta kuno kay kanang uh, more complex siya kaysa y connection. So the delta connection is more complex, complex and is easy to mess, and it's easy to mess to the Y connection. So in part 1, we will discuss and try to observe and draw the delta Y connection. So we will draw and observe delta Y connection. So let's begin with a single phase transformer with 2 windings. So then so this is our transformer, and this is the polarity. These two dots here is the polarity, and this is our secondary voltage, or the secondary side, or the secondary low voltage. This is our primary voltage, or the primary side, or the right side, high voltage. Then this two parallel line here, this two is our magnetic two parallel lines. So to make this three phase, we will add winding A, and winding C. So it will look like this na. So to make this three phase, we will start by connecting the secondary winding, where we're gonna connect over A, B, and C. So to connect this, and in our primary voltage, we're going to connect it. And in simplicity, we're going to ground our neutral wire. So to ground it, so delta Y grounded, this is called delta Y grounded transformer connection. In part 2, we will try to discuss the relationship to line voltage and phase voltage for delta Y connection. So let's try to illustrate our three phase there. So our transformer, three phase transformer is illustrated na. Then this is our primary voltage. This is our secondary voltage. Then this is our line A, line B, and line C. So we will establish our connection. And also we will establish our connection here in the primary side. After we build our connection, let's build the ground. So line to line connection ko no is the measure across two lines. So muna siya ang line to line connection. Then we should expect that our line to line AB is equal. So our line to line AB is equal to our phase A. And we should also expect that our delta connection across two lines is equal to the voltage across our winding. So simply, our line-to-line voltage AB is equal to phase voltage A minus phase voltage B is equal to square root of 3 phase voltage. So also this is our this is our line to line AB. This is our line to line AB and this is our line to line BC. So the equation for the line to line BC is equal to phase voltage B minus phase voltage C is equal to square root of 3 phase voltage B. And then we will let our primary voltage to equal to 4160 volts, while our secondary voltage will be 480 voltage. So if we measure the line to line AB, so it will equal to 4160 voltage, and so on. VLL B, VLL C, so equal na sila og 4160 voltage. So the other side naman, so we will also remember that line to line AB will always equal to phase voltage A minus phase voltage B, so which would equal to square root of 3 phase voltage. So to solve this, we will have to 480 voltage is equal to square root of 3 phase voltage. So phase voltage is equal to 480 divided by our square root of 3. So phase voltage will equal to 277 voltage. So in part 3, we will try to define the line current. So line current and our phase current for Y connection. First, we will make our transformer. Diba, for part 2, kaya nga to primary kay natay 4160 voltage, then our secondary naatay 480 voltage. So like in part 2, we will try to label this. So first, our line A, line B, line C. Then our line A will be the line to line A. Our line B will be line to line B. Our line C will be the line to line current C. So the current that flow through this line will be our conduction. So this side here will be our load. Then let's try to establish our connection between transformers. So in our secondary side, the flow of currents are clockwise. So this will be called phase current A, phase current B, phase current C. So in our primary side naman, so the flow of currents will be counterclockwise. Then this will be called phase current A, phase current B, phase current C. Same as also this will be called also the line to line A, line to line current B, line to line current C. So remember that our primary side will be the source or the generator, utility, grid. And also remember that the phase current A is equal to line to line current A, ha. Then that will describe the place or the place of our line current. In part 4, we will try to discuss the relationship between line current and phase current for delta connection. So we will try to draw our transformers, three-phase for transformer. So this will be our three-phase transformer. So remember that phase current and line current are both equal. So phase current and line current are equal. Then this line here, let's label this as note A, note B, and note C. So the current of the current from phase A will flow directly to node A padong sa node B. Then the current from the phase current from B will flow to node B. The phase current from C will flow to node C and will mutuyok siya. So para ma-describe nato ang relationship between line to line, para ma-describe nato ang relationship between line to line current and phase current, kay mugamit ta og Kirchhoff law. So we can usually verify that line current A will flow to node, the line current A will flow to node A. Then same as line current B will flow to node B, and line current will flow to line C. So as we can see, we can apply Kirchhoff law. So as we can see, in applying Kirchhoff law, we can use that line to line A plus phase C will equal to phase A. That's how we describe that the relationship between line current and phase current for delta connection transformer. 5. The phasor analysis. So as we can see, sa ato part 4, we came up with this equation through this. So let's try to make the equation. So line to line A plus phase C will equal to phase A here. Then sa note B, we can see that line to line B plus phase A is equal to phase B. While sa diri na note, sa note C nato, makita nato ang line to line C plus phase B will equal to phase C. Then nakuha nato ang equation. So we will try to rewrite our equation. So this will become ILL A is equal to phase A minus phase C. Then ILL B is equal to phase B minus phase A. Then ILL C is equal to phase C minus phase B. Then this is our equation for this transformer. So phase values so phase values are the current that flows through our windings, to try to re-evaluate our equation. So in our our current A will be 1000 ampere, then 0 degree, then our current B will be 1000 ampere, then 240 degree, then our current C will be 1000 ampere, and 120 degree. So in order to graph that in our phasor, we will draw a circle. This will be our reference, 0. So this here will be the current A. Current A, 1000 ampere, 0 degree. This here will be our current C, 100 current C, 1000 ampere, 120 degree. This here will be our current B, 1000 ampere, 240 degree. So we will try to compute the particular equation. So line to line A is equal to phase A minus phase C. So what we were saying is, if we subtract phase current A minus phase current C, we will get line to line A. So this this graph is called head to tail. So in order for us to get this equation, we will subtract phase A minus phase C. So this is our phase A. Then we will going to remove our phase C and add it here. So this will be our phase C. Phase C. So phase A, then minus phase C. Then so for us, phase E is, so equal na sila og ILLA. So we will add this line here, and this will be our ILLA. So line to line current A. This will be our line to line current A. And all we are saying is, if we compare the phase A with the line to line A, we will see that line to line A is larger than the phase current, and it is also has 30 degree. So we can say that ILLA, or line to line current A, is going to be square root of 3 larger. So this one. We know that line to line B is equal to phase B minus phase A, and line to line C is equal to phase B minus phase A. So we will try to draw our phase. So I line to line B. So this will be our point of reference. This will be the 120 degree, 240 degree, then our 0 degree. So phase C. This will be our phase C. Then we will try to remove this and move it here. This will be our phase A. So we will draw here our ILLB, or line to line B. This will be our phase A. This will be our phase C. So phase C minus phase A is equal to line to line current B. Same as I mean the magnitude. We will have a magnitude of square root of 3 times phase B. So this one here, and having a lagging of 30 degree. So nana siya 30 degree nga ra. Tungod nana siya 30 degree diha. And it is rotating in a counterclockwise. So counterclockwise. Then ang sa ato line to line C, ang line to line C na to. So we will have to draw a graph. Then this will be our reference. Then our 120 degree, our 240 degree, our 0 degree, ILL A, ILL I mean phase A, phase B, then phase C. So ang ato gipangita ang phase C. So ang phase C mo equal siya og B. So B. So this is our phase B. So i-add na to, minus na to si phase A. So we will going to remove this and add this here. So ang iya porma na nag-ana siya. This will be our phase A, then phase B. Then this will become our ILLC, or the line to line current C. Then who had also a 30 degree lagging 30 degree, and a resultant vector of square root of 3 times phase current C. So we have drawn our diagram. So we added all our equation. So this will be the line to line A, line to line B, line to line C, who had a 240 degree, 120 degree, and 0 degree. This example is a balanced set of line current. So this is the complete phasor. This is a complete phasor diagram. We see that the line current has the same magnitude and has a 120 degree difference. So pareha sila magnitude, ug na sila 120 na difference. So 120 here, 120 here, 120 here. Okay. Part 6. Voltage phase diagram for delta transformer connection. Voltage diagram for delta transformer connection. So the delta has no ground, but some sources is tied to the ground. That ground is the sequence for this transformer we're going to assume. So sa ato part, makita to nato ang transformer. So mag-assume ta, di ba? So here, we're going to draw. So we have drawn our transformer. So as a part na to, this will be our line A, our line B, our line C, so here, this is our transformer. Here will become our source. This will become our source. And na nagtied sa ato ang ground. This also here will be our source. So we will try we will try to connect this ground over here to the Y side now. So it's connected. So it's already connected. Then we have established na our we will establish our voltage na across the line. So on the ground we will gonna call this VAG, and VBG, and lastly VCG. This will become a VAG, VBG, and VCG. So ang take ani kay we should understand the voltage phase is really rooted in the understanding of VAG versus VAB. So asa ka ng V mo ang voltage A, G, ground. Ang G mo na tong ground. Ang G mo na tong ground niya. Voltage A mo na to line A, yeah, G, connect voltage across AG. Same as VBG, voltage across B, line B to the ground, and VCG, voltage across the line C to the ground. Di ba? After that, kay mag-balance power system ta. Balance power system. So, ang VAG na to is equal to 2,400. Let's assume lang ha. Then 0 degree. Mga to, VBG is equal to 2,400 also. 240 degree. Ang ato VCG is equal to 2,400 also. 120 degree. Then, let's try to evaluate the equation. So, we can say that VA VAB is equal to phase voltage A is equal also to VAG minus VBG. Kusong sa ako kanilang. Tabi sa karo. So sa ato phasor diagram mahimon na siyang inani. Reference, di ba this is our VAG. This will become our VAB, di ba? And I mean this will become our VBA rather. VBA and this will become our VAB. Di ba? Di ba tanaw agad? VAB. So this will become our VAB, di ba? Kanina point will become our VAB. So VAB minus VAB is equal to VAG, our VAG here, point of reference, then minus VBG, ato i-add ang VBG nga rin. We want to understand the relationship between VAG and VAB because that was going to help because this will help up to make our phasor diagram for delta connection. So from this diagram we can get equation. So VAG, VBG and VCG. So here you can see that VAB is equal to square root of 3 VAG 30 degree. VBC is equal to square root of 3 VBG square root 30 degree. VCA is equal to square root of 3 VCG 30 degree. So this equation is coming right here. Ato gikuha ang kanina equation nga ri. So ang kani siya ato na po ni siya himuan og phase diagram. So VAB is the voltage across the line to line, same as VBC and VCA. So let's draw a phase diagram. In this phasor diagram, 'di ba, we have VAB na. This will become our VAB. VAB. Then V is equal to VAG minus VBG. So ang ato VAB kay equal din siya sa ato phase voltage A. No, di ba? Then ngari sa tuang 240 degree mo ni ang ato VBC. VBC na to siya. Kay ang VBC kay VBG minus VCG So mao ni siya ang ato VBC. Kani mo ni siya to VBC. Kay ang VBC is equal to VBG minus VCG. Nya ang ari dapit na part mo ani ang ato VCA. Kay ngano ang VCA biya, ang VCA kay VCG minus VAG. So muna siya ang kanina part mo na siya ang atong VCA. Kay ang VCA mo man siya ang VCG minus VAG. So nanatay phasor diagram. Now ato i-label ang ato ang diagram. So ang VBC kay equal dahil siya sa phase voltage B, then ang VCA nato kay equal di ay siya, ang VCA kay equal di ay siya sa phase voltage C, diba? So ato na ginibelan. So we were going to represent the polarity by putting the dot here. So ang polarity di ay ang polarity na makita nato, ang polarity, ang kanisya ng mga polarity, ang kanisya ng mga polarity nga ri, di ba na siya mga polarity nga ra, di ba mo na yung mga dot mo ng polarity, ato na siya ibutang diha kay para dili ta maglibog ug mo represent pud siya sa ato line to line. So mao ni ang polarity. Sample araw na ha ang direction. So nanatay polarity. So naa di ay tay kanang duha ka klase sa phasor diagram. Ang kani siya na diagram mo ni siya ang kuan siya, mo siya ang gitawag na open form phasor diagram. Then ang kaning usa na atong himuon karon kay mao dayon siya ang close form phasor diagram. So ato i-drawing yung phasor diagram. Di ba mo ni ato reference, point of reference. Then ang di ba ang kanisiya ang sa ato ang sa ato VAB, ang ato ang VAB, line to line VAB kay kani siya ma-move ni siya ngare maana ni siya ngare i-represent ang polarity. Ang ato VA, ang ato VCA, ang ato VCA kay ma-move ni siya ngare ang ato VCG, ma-move ni siya ngare. So muna siya ang closed form phasor diagram. Ang ato A, ang ato B, ang ato C. Muna ato ang A, muna ato A ha, ang A ha, muna siya ang VAB, muna siya ang VCA, muna siya ang VCG. So ang close phase diagram kay makawintaliting ta na ang triangle, ang kanyang triangle naka-represent sa voltages. Naka-represent siya sa voltages, power system. Pero sa actual di ay naka-represent din siya sa line to line. Sa line to line of delta. Mun siya ang mga line to line delta. But mo equal pud siya ang kaning line to line nato, ang kani siya mo equal din ni siya sa ato winding voltage. Voltage, line to ground voltages is interphasor. Muna siya, ang kanin nasa center, muna siya ang mga interphasor, ang katong mga phase current. Second one kay ang closed form diagram kay nakatingta na ang origin niya, ang kaning origin nagrepresent ni siya sa neutral sa ground, pero dili day. Ang ikatulo kay ang VAB, VBC o VCA kay nakita nato sa ato ang gidraw sa ato ang particular map, kay mauna siya ang voltage drop, pero dili di ay, kay pwede man to siya tawagon na voltage drop from B to A, from B to A, voltage drop from A to C, A to C, voltage drop from C to B, which is dili de. Kay pero nga to adi gisuwat kay VAB is equal to phase voltage A. Mao jud na siya. Og sum sa VCA is equal to phase voltage C, og VBC is equal to phase voltage B. Mao jud na siya. So ang naka-benefit aning closed form kay provide siya o makahibaw jud ta kung ang transfer is kanang winding connected, di ba?